Hello everyone, my name is Samuel Osung and welcome back to my YouTube channel. In this video, we are going to look at TLS in Kubernetes. TLS is a very crucial topic for securing applications. So by the end of this video, we are going to understand what TLS is and why it is important. And we are also going to look at how TLS termination works. Then we are going to see we are going to demonstrate how we can get TLS for our cluster. All right. So please, before we continue, if you are yet to subscribe to my YouTube channel or this is the first time you are here, please do well to subscribe to my channel and like this video. If you have any issues or if you run into any problem while demonstrating with me, you can drop your questions in the comment section and I am going to do well to reply to them. Let us continue. So whenever a browser talks to your application, all right, whenever a browser talks to your application, traffic flows from the browser to, let's say, you have the ingress here. Second. Okay, let me use this. So traffic flows from the browser to the ingress. Of course, the ingress is where the load balancing, or the ingress or the load balancer rather. Then from the ingress to the service, then from service, then to your port. Now without TLS, this here is the traffic flowing through this means is in plain text. So anyone on the network can intercept things like your passwords, can also intercept cookies, even some tokens. Now TLS solves three things. It solves encryption, it also solves identity. Then of course TLS also solves integrity. Now some people refer this to as SSL. SSL is old, all right? TLS is the modern stuff, but people still say things like SSL certificate. Now let us look at the two common types of TLS termination. Now there are two common places to terminate your TLS. The first one is at the load balancer. And the second one is at the ingress controller. Now, terminating TLS at the ingress, at the load balancer is the easiest one. So let's assume you are using AWS native service or native services. You can simply go to AWS, get get a certificate for your domain, all right, then attach the certificate to your load balancer. Can be the IP address of the load balancer, it can be the endpoint of the load balancer, and this works. All right, so it So when traffic flow, let's assume um, that I am here, okay, and I am using the browser. So this is, of course, going to use a load balancer. Then from the load balancer, we have the cluster. Then inside the cluster, of course, we have the ingress controller IC. All right. So that means the traffic flowing from the browser to the load balancer is simply HTTPS. HTTPS. Now, from the load balancer to your cluster is in plain text. All right. Then how about we terminate the TLS at the ingress level? Now, we already have an ingress controller. All right. So what actually happens is that if you also take a look at this guy, traffic flowing from here, from the browser to the ingress controller is HTTPS. From here to here is HTTPS. And the rest of the traffic flowing inside the cluster is what? In plain text. So these are the differences. So before we create a certificate, let us understand some very important concepts. The first one is a certificate manager. So a certificate manager is simply a Kubernetes controller. It is a Kubernetes controller that automates certificate management. All right. So that means the responsibility of a certificate manager is to request, it is to renew, then it is also going to store the certificate. And of course, reload ingress with the updated certificate. So that means without a certificate manager, you would have to manually create, renew, and update certificates. And of course, this is not scalable in production. Another resource we are also going to look at, or another thing we are also going to look at, is cluster issuer. So a cluster issuer is a Kubernetes resource that defines the authority for issuing certificates. So you can think of it as a certificate factory. You can think of it as a certificate factory. All right. So cluster issuer knows how to get a certificate from a particular certificate authority. Now we have so many types of certificate authority. All right. We have less encrypt. We have DigiSets. All right. We have a whole lot of them. Now we have two main types of certificates. We have the self-signed certificate. Then we also have the production grade certificate. So for the self-signed certificate, um, A self-signed certificate is a certificate you made yourself. All right. It is good for testing, but it is very bad for production because browsers and applications will not trust it. Okay. Now, the production grade is the one that comes from a known certificate authority. So I took my time to explain this concept in one of our HA proxy videos. All right. I'm going to highlight this video here at the end of um this video. All right, so I'm going to highlight the HA proxy video that refers to the self-signed and production grade certificate at the end of this video. So the production grade is one that is gotten from a well-known authority. That means you need to have a trusted domain, first of all, before you can even request a certificate from the CA. So again, self-sign is only trust by you. All right. So you can use it for your let's say your workloads in the cluster, inside the cluster, like your back-end application, your APIs, and the rest of them. But it is actually very popular for local testing. So first, for us to get our certificates, we are going to do what we are going to install certificates manager in our cluster. Then we are going to create a cluster issuer resource. Then we are also going to create a certificate resource, the main certificate resource. So the first thing we are going to do is to install certificate manager in our cluster. All right, but first, let us check if we have a running cluster, kubectl, get nodes. Okay, I'm using a minikube cluster, so you can also try this. Try this with minikube. All right. Now we are going to do what? Install certificate manager. So to install certificate manager, we are going to use Helm. Now, Helm is a package manager for Kubernetes. So in a later video, we are going to discuss much more about Helm. But for now, understand that Helm is used to package an application, then install it on Kubernetes. All right. So with this, you run this command the way it is. All right. So the first one is to add the Helm, to add the Jetstack chat to your Helm repository, update the repository, then install certificate manager. So this guy is going to do what? He's going to install the he's going to create a namespace for you, then install this version of certificate manager. Then it's set, since certificate manager is not a vanilla resource in Kubernetes, it is a CRD. Then you set install CRD is equals to true. All right. So when you do this, you are going to end up with a certificate manager installed in certificate manager namespace. So we'll do kubectl get namespace. All right. So then let us proceed with our installation. First of all, I will copy all of this. All right. Then paste it on my terminal. Please, you need to have Helm. You need to have Helm already installed on your laptop. So you give it a second, and this is going to create a namespace and then install your certificate. So depending on your internet connectivity, but it's usually very fast. All right. So I'm going to pause this video, then resume when our certificate is successfully installed. Or sorry, when our certificate manager is successfully installed. successfully deployed. All right. So remember that it's going to create a namespace for us. So if I do kubectl get namespace, I should see a new namespace here, set manager. So let us check if our if all our ports for the certificate manager is deployed correctly. So I'll do kubectl get ports, get ports -n in the set manager namespace. If I hit enter, sorry please, kubectl. So all of our ports are in all of our ports running in the set manager namespace is running correctly. All right. So this is our key injector, this is our webhook, and this is the main set manager controller. So we are going to deploy a self-signed certificate. So first, the very first thing we are going to deploy is we are going to deploy a very small port. Then from there, we are going to deploy a service, then ingress, then we are going to apply the cluster issuer for the cluster. Then we'll go ahead to create the certificate for our domain. So I have a demo app here, Nano. So this is going to create the deployment for one replica for application and the service of kind cluster IP. So I'll do kubectl apply -f, then demo app. All right. So the deployment and the services are configured. So if I do kubectl get service, this is the new service we created. Kubectl get deployment. So I have our deployment up and running. All right, so we'll also need an ingress. Okay, so I have a very minimal ingress for our deployment, which is all right. So the host is demo.local. The host is demo.local, and there is no path here, so this is empty. Okay, so again, this is okay. Before we look at, because we will need to reference our certificate in the ingress. So before we apply our ingress, let us create a certificate. So if I do nano all right, so this is a cluster issuer for a self-signed certificate. So the specification here is self-signed, and the metadata here, this is what the cluster issuer is going to assume, and we are creating an object of kind cluster issuer. And since this is a CRUD, this is the API version the certificate manager belongs to. So kubectl So you need to apply the cluster issuer before getting your certificate. So kubectl -f self-signed cluster issuer.yaml. All right. So if I do kubectl get cluster issuer, I can see that my cluster issuer has been created and it is ready. It was created 9 seconds ago and it is currently ready. So let us look at our certificate request. So this is a certificate object, all right, and this is the name the certificate is going to assume, all right, and the secret name is web self-signed, all right. Now the issuer ref, this is where a certificate is going to be stored. Now we have the issuer ref. The issuer ref is pointing to our self-signed cluster issuer, and the DNS name spec dot DNS name is where you input, or is where you specify the DNS name you are getting this certificate for. But since this is a self-signed certificate, I can input any DNS name here. All right. But for a production grade cluster, you need to have a true and a verified DNS name. So let us go ahead and apply this certificate. So if I do kubectl apply -f all right, so if I do kubectl get certificate, so I can see that my self-signed certificate is ready, and this is the name, and this is where it is stored. This is where the secrets are stored. That is the .crt, the .perm, and all those stuff. So this is where it is stored. So I'm going to reference this certificate in the ingress, because the ingress is going to use this certificate to terminate TLS as the ingress controller. All right. So if you check, let us take a look at our ingress again. So the only thing that changes is the TLS under the spec. So we've added the host of our um, um, the host of or the domain name of which we got the certificate for, which is demo.local, and the secret name, we reference the secret name, which is web self-signed TLS. So let us go ahead and apply this ingress. So I'll do kubectl apply -f self-sign ingress.yaml. So our ingress has been created. Okay, now if I do kubectl get ingress, so we can access our ingress through this host, but we also need an address of which we will map this host to. So let us wait for our ingress to get ready. Then we do kubectl get ingress again. And of course, if you can confirm with me, you can see that the ingress is also can be accessed through 443. So we'll give it a second, because since this is not a real domain, for us to be able to access this domain, we will need to map this domain in our local computer, so that the local computer will assume that, or will resolve it to our ingress IP. All right. All right. So we are going to map this. For us to successfully map this, then you need to go to Go to etc, and in etc you are going to see a file called host. All right, so map that domain demo.local, map it to the ingress IP address. So that means when you try to access demo.local, it is going to be resolved to this domain here. All right, so if we go to the website and all right, so there's a potential warning here that that demo.local uses an invalid security certificate. The certificate is not trusted because it is self-signed. All right, you can either accept the risks or go back, but since this is demo, we accept the risks and we are greeted with welcome to Nginx. So if you check, um so if you check demo.local, this website does not supply ownership information because it is a self-site, and if we view, you can view the certificate from here. All right, so this is how you can get a self-signed certificate for yourself. Now, for the production grade certificate, it's almost the same thing. All right, but for your production grade certificate to work, that means you will need a valid domain. Now let us take a look at um let us take a look at a cluster issuer for a production grade certificate. So the kind is cluster issuer. All right, now this is what changes for the spec. Now we are getting a production grade certificate from Let's Encrypt, and the way Let's Encrypt verifies your domain is to um um is to do an ACME challenge to actually verify if that domain belongs to you. All right, so here you are going to specify your correct email address. You are also going to verify the server. Of course, this is the correct one for Let's Encrypt. Okay, and for the solvers, you make sure that you use the correct ingress class here. So for the certificate, the certificate is also the same thing like we saw before. All right, so this is just the metadata name, but this is where everything changes. So your for the issuer ref, all right, the issuer ref we refer to the cluster issuer, all right, then the kind and the DNS name. You should make sure that this is a correct DNS name, then reference that DNS name, reference the DNS name in your ingress. So ingress does not talk to your, it is worthy to note that ingress does not talk to the cluster issuer. All right, cluster issuer and certificate manager handle certificate creation, renewal, and storage. So the only thing that ingress do is just to consume the secret. Okay, so if you have stayed with me up to this time, so I so much appreciate you. So for your um practical, you can also try to create a self-signed certificate, then get a real domain, maybe from Namecheap, GoDaddy, or you can even get one from AWS. Then try to get a production grade certificate from Let's Encrypt. If you have any question regarding this, then you can drop a comment with your question and I'm going to reply to it. And also, please do well to subscribe. You can share this video with your friend and also like and comment on this video. So I'll see you in the next video. Thank you.